Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Scylla. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you just like to share it after the fact, you'll receive an email with a link to access the webinar on demand. If you look to the right side of your screen, you'll find a Q&A tab. This is where we want you to send in any questions you have for our speakers today. And if you just want to contribute to our conversation or let us know where you're tuning in from, we want you to use that chat tab. We do have 2 polls included throughout today's presentation, so keep an eye out for whenever we launch those. And finally, at the end of the program, we will have a drawing for 4 $25 Amazon gift cards. So on to our topic today. It is overcoming barriers of scaling your database. And I'm joined today by Peter Corless, Director of Technical Advocacy at ScyllaDB, and Tomer Sandler, Head of Customer Success at ScyllaDB. And it is my pleasure to turn the floor over to Peter and Tomer to get us started. Thank you so much for being here with me, you guys.
Thanks very much, Cody. Hello, today we're going to talk to you about overcoming barriers of scaling your database. First, though, I would like to push a poll question to you. We'd like to get to know about you, our audience, and understand your perspectives on distributed databases. For some of you will be interested in SQL, and some NoSQL, and some both. For those of you interested in NoSQL, where are you in your NoSQL adoption? I currently use ScyllaDB. I currently use another NoSQL database. I'm currently evaluating NoSQL. I'm interested in learning more about ScyllaDB, or none of the above. Totally fine. All right, we'll close out this poll once we've given you a chance to answer and then move on. My name, let's go to the next slide here. My name, by the way, is Peter Corless. I am the Director of Technical Advocacy here at ScyllaDB. I listen to our users' stories and discover wisdom in each to share with our other practitioners in the industry at large, whether through blogs or through technical presentations. Today, I'm happy to be joined with my colleague, Tomer Sandler, who, due to his dedication, experience, and insight, became the head of ScyllaDB's customer success organization. Before ScyllaDB, Tomer worked at Dell, Variant, and EMC. With 20 years of experience in industry, Tomer has seen the rise of the public cloud and distributed databases and brings with him a wealth of knowledge. He also plays a mean saxophone. So, now let's take a look at this. Let's take a look about the database we know and love. ScyllaDB is the single most reliable database for data-intensive applications which require high performance and low latency. Our universe of users manage game-changing applications which require monster scale. Because this is advanced architecture, ScyllaDB provides superior system utilization, resulting in higher performance, lower latencies, and better ROI on your infrastructure. ScyllaDB is available as pure open source, enterprise edition with value-added features, and a full enterprise support, plus a fully managed database as a service, Scylla Cloud. Here's a quick snapshot of some of the many companies using ScyllaDB. As you can see, it's not just one industry. Anyone looking to run a big, fast, always-on distributed database can use us. You can start small and keep scaling. There's no barriers to hit as your company or your use cases grow. Start small, think hugely. Also, if you want to learn more, Scylla Summit 2022 is coming up February 9th and 10th, just next week. It is our annual free online user conference. You can find the registration page at ScyllaDB.com/summit. I am the content chair for this year's summit, and I have been busy working with all of our great lineup of speakers. As ever, we'll have our ScyllaDB executives and our engineers, plus industry leaders and use cases from our open source as well as our cloud and enterprise customers. And we have some great sessions lined up, and I'm sure you're going to love it. With that, let's just get on with it. What I'd like to do then is we're going to show you some questions. And let's just join Tomer here and see how he answers some of these things. So Tomer, first question to you is, how does a company know when they've hit the scaling wall?
So it's usually some observable performance impact and or unavailability. It can be somebody complaining about something, either users complaining about their experience. It can be the infrastructure, people saying that it seems that we've exhausted the resources by some monitoring tools that they have. It can be the developers that are saying that they're seeing weird behavior. And of course, in the worst case, it can be all three or some interlock of multiple stuff that can cause a partial outage or a full outage.
Right. So sometimes these things can be like very instrumentally seen. You can see this clearly on the graph. So your performance, your op center. Sometimes though, it's going to be just anecdotal, right?
Yeah, it can be people from your knock center or your monitoring start seeing weird behaviors or latency starting to climb, the tail latency, the P99 or 95 or P39s. And it can be even your users starting to complain in whatever communication means they have with you about slowness, about rendering issues, about loading issues. Yeah, it can be one of those usually.
Exactly. Okay. So let's talk about in specific. Some of the times the limits are hit in throughput, right?
Yeah,
And sometimes your throughput limits might be because somebody just added a new workload. They said, "Hey, I have a database. Let me start querying it in ways it wasn't designed to do." Or maybe they've added more data or new columns to the data.
yeah,
And so that's adding additional workload to an existing database. And sometimes it's a time of day burst of traffic, right? Increased daily usage. So why don't you talk about these two different kinds of things, these new workloads versus bursty traffic?
yeah. So many times you start off with a specific use case, maybe a few tables, maybe one microservices or two. But once you get things going and things are working well, um, some new developer team decides, well, I want to use that database as well, and why not let's add some more tables and key spaces of our own with some more microservices of our own. And suddenly, the cluster that might have been sized properly to support a few microservices is now supporting 5x or 10x that amount. And basically, either you'll start hitting the issues that we talked about earlier, performance issues and overload issues and stuff like that. And that's why it's very important to know how your system is going to degrade beyond its peak performance.
Right.
Okay, you need to prepare for that, and you need to still be able to sustain that while you're catching up with that additional workload that came in, either by design, because just more
Hmm.
people started using it, or your user base of your product suddenly spiked because of some successful, some amazing success, and you're being hit by 10x the traffic. So that can be something that can be bursty, right?
Yeah.
There was some news event. There is something that is happening, a sports event that is now making 10x users coming to your website or whatever. And for that, you need good planning, and you need to make sure that it doesn't matter really how good your hardware resources are. If you
Hmm.
underspec your system, you can hit those issues. Okay. Uh,
Yeah. Now, and I think that gets into like the infrastructure you've chosen to build upon, because some infrastructure is tolerant of, let's say, workload shedding or prioritization, and other infrastructure is kind of very fragile when it hits performance limits. Why don't you talk about an example of this with, like, let's say, ScyllaDB's workload prioritization? What does that do, and how does that help you alleviate when you hit these kind of limits?
Yeah. So first of all, not all softwares and databases are created equal.
Yeah.
Some handle async performance or async requests coming from the software in a better manner, and some others do that in a less good manner. Another thing is that, for example, with ScyllaDB, we have the workload prioritization that you can set the amount of shares and the compute resources and the I/O and bandwidth that each request would have, or each workload would have. You basically use the role-based access feature, assigned that to each of the workloads that are coming into the cluster, and each one of them can be assigned the shares, and the one that will have more shares will have, in a case of contention, which we're talking about here, will have more priority over others. So that's something that can alleviate that, but again, there's always limits to that as well, including the amount of various workload that you can prioritize. It's not indefinite. So nothing replaces good planning and good observability. You want to basically try to look to longer time windows, beyond the week, beyond the month, and you want to see the rate of your data grow, the rate of your traffic grows, and to try to extrapolate on that to prepare for those issues.
Right, because once you're past 100% utilization, you can ameliorate the problem or prioritize something that'll be less affected, but you can't get rid of going past the capacity of what you originally planned, right?
Exactly. If you're talking about storage, then once you're getting close to no disk space left, then that's the end game. You have to basically not hit that and scale before.
Right. Okay, let's go on to the next point then here. Even with the best upfront planning, you can run into, this is what you were talking about before, the stochastic event, the dress that broke the internet, the day that some article that goes totally hot, and this is different than, let's say, the lunchtime or commute hour crowd. This is something that was, you can predict that you're going to shoot the moon someday, but you can never know when that day is going to be, right?
Yeah.
What then?
So let's say unlike some kind of an expected high traffic event like Black Friday, Cyber Monday, where usually you scale upfront. In this case, this will require something that is called like an emergency scalability. Okay, you're hitting this situation. You identify that your cluster is overloaded. And you start seeing issues. Okay, so it could be that if it's something that is happening so fast, you might not even be able to complete your scaling out before that event finishes. So that's why, going back to the previous point, you need to make sure your cluster will be able to sustain a good service beyond the peak. Okay, and it could be that some people will experience some slowness. The P95 or 99 won't be as great as you want it, but things will still continue to work. Now, in case this is going to be a prolonged event, you do have to go into emergency scalability and start doing things really fast. And then it depends, where exactly are you? Are you on-prem? Are you on cloud? What resources do you have available for you to do that? How fast are you going to be able to stream the data and join more nodes into the cluster? So all of the things is things that you need to plan and maybe even practice those to such stochastic events upfront.
Right. And I think the other thing too is that a stochastic event can reduce capacity. We had a customer that lost 10 nodes out of 30, right?
Yep.
So those are that's what I would call a torpedo test. How resilient or is your system in the case of loss of planned capacity?
Exactly.
Because go ahead.
Yeah, we had a customer that was deployed with all the good practices on multi-data centers, and he suffered a big fire in one of the data centers. Nothing related to him. It was a fire in one of the data centers, which took out a third of his cluster and a third of his nodes. And the reason that he was able to sustain that was because he was already deployed on 3 data centers in advance. He was able to redirect all the traffic from all the application clients that were supposed to be serving by that data centers that got hurt by the fire to the 2 other data centers. The cluster was properly sized to be able to carry that additional, let's say, in average, 33% from that data center distributed into the two others. So each data center had to absorb another 15 or 20% additional load. And he was able to do that while the cluster was being while the fire was being handled. And only like a few good months after that, he was able to add that third data center back again.
Yeah, and so this also gets into things like, for instance, Scylla was able to do this also because it's got a built-in row-based cache. So it didn't require an external infrastructure piece. It was built into it, so it could absorb that kind of stuff. And again, a kind of a built-in cache allows you to serve out a lot of reads. Would not have helped in a heavy read-write situation where you're trying to do updates, because cache wouldn't be applicable then. So I think that again, everybody's got to think about how this is going to be applicable to their specific use case. Again, high cache hit rate situation, that kind of offload really does help. Again, if you're having a highly interactive workload or a write-heavy workload, you also have to think about those kind of capacity plannings too.
Exactly, and in Scylla, your writes also go through the cache unless you decide to skip the cache. There's an option for that, and we really want your cache to be populated with the most recent data. So as much read requests will be able to be served from the cache. Another thing that you need to make sure that you don't start creating, for example, bad queries that are polluting, quote unquote, your cache with prepared statements that keep changing all the time, and that's why they keep polluting the cache. More new prepared statements coming in, old ones being evacuated. That's something that can cause also latency issues. But again, that would be something that you're doing wrongly, and with our observability and great monitoring, there will be an indication for that, which can help you identify that.
Yeah, and then I think the other thing too is that we also have a method in the scheduler so that, let's say, repairs could be deprioritized, so that in a heavy transaction situation, the system itself detects that and backs off repair process as another overhead.
Exactly. The IO scheduler is planned to have always in priority the real-time traffic, the requests that are coming from your application. Anything else that is going on in the background, like streaming, repair, compactions, will get deprioritized if the system cannot catch up. Of course, it's all a matter of checks and balances and how much compute you have available at that point in time. If there's enough available to go around, everyone will get as much as they need. But again, if we're hitting some sort of a contention situation, then Scylla is an autonomous and self-correcting database. It will prioritize the real-time traffic and your users over the background stuff that are happening.
Right, and again, that's automatic, which is cool because again, if you have to have an administrator to log into the system and issue that kind of like back off command, then that takes you real-time cycles, right? This is all adaptive, it's all real time. And I think that that's what people should be looking for from their infrastructure going forward.
Yeah.
Okay, so we've been talking about this. In fact, I think you defined emergency scalability as responding to the unplanned demands on your system. Can you give us more examples of what you've seen in terms of emergency scaling limits in the wild? We talked about unplanned outages. Is there any other examples you can think of?
Yes, and again, if in the case you're using, for example, a bare metal and you don't have sufficient resources to continue to scale, and then you have to go to procurement and start cycles with them to get that additional hardware, that can be, of course, a long cycle, which will hurt your ability to scale.
But even if, I mean, so a lot of people think about that with, like, let's say on-premises procurement, but that can also hit you in the cloud, especially if you're using some of the latest nodes and they're not available in every region or they don't have them sufficient quantities.
Exactly. So when you're going to the cloud, it can minimize that impact, but it cannot eliminate it, right? You're depending on the availability per region. You're depending on your quotas. If you maxed out on your quotas, If you have other infrastructure like VPC, subnet, and other infrastructure resources that you maxed out on those, it can be 24, 48 hours until you get approval and increase your quotas, and you can deploy those. So there can be also delays in the cloud, even though we all think that it's always super elastic and easily scalable.
Exactly. It's not magic then.
Yes.
So now we talked a little bit about this, but let's talk about more about emergency scaling on premises versus the cloud. Do people actually provision, like, let's say, do they have additional hot standby or I should say like, on-site replacement nodes, things like that, or to add to the cluster?
Sometimes they do that. In the cloud, they usually don't, because usually, again, if they are okay with their quotas and everything, they will be able to achieve that. But we do see the multi data center, and it can be a mixture. It could be on-prem and an on-prem. It could be an on-prem and a cloud. Okay, Scylla gives you the flexibility to join on-prem and cloud data centers in one data center. And we even had a few customers that were doing that.
Oh, you mean like as one cluster? Like it's the
Yes,
same
one
Scylla
cluster that
cluster?
is made out of two data center. One is on-prem and one is in the cloud. You can even make a cluster that is made out of cross clouds, which is like you're not only able to sustain, you're not only planning to sustain maybe an availability zone going down. You're not only planning for a region going down. You're planning for a full cloud vendor going down, which is like rare, of course, but yeah.
So for our audience, I just want to let you know, we're going to have a demo of that at Scylla Summit a week from now. Sada is going to show about how to run Scylla using Anthos on multi-cloud situations. So Azure, AWS, Google Cloud, all at the same time. So that's going to be a great thing. So, but I think also what you're talking about too, about having on-prem and in a public cloud is also interesting, because, for instance, people might be doing their transactions out in the public cloud, but then using their on-premises just for the analytics, right?
Exactly, and sometimes we do see that some customers fall back to the workload prioritization to prioritize analytics, OLAP and OLTP workloads, but some do prefer the old method, which is still good, to have an analytics data center, which you only need to replicate your data maybe once there. You don't need the multiple replications, so you're saving on storage, because you only need that data center as a disaster recovery possibly, but mostly as analytics for your weekly, daily, monthly reports or anything. And the other data center is for your real-time traffic.
Very good. Okay, here's a second poll question. Thanks very much for everybody for attending here. I want to find out again more about you. I'd love to hear what you guys say about how much data you have under management in your operational database systems. So we're not talking your data lake. We're not talking about what's stored on tape and backup. We're talking about, like, under your active OLTP kind of databases, do you have less than a terabyte of data that you're managing? This is non-replicated, so we're not talking about their triple replication factors or anything like that. But just your primary data set, is it less than a terabyte? Is between 1 and 50 terabytes, 51 to 100, or greater than 100 terabytes? So just let us know how much data do you think is big data?
Yeah. And that would be a good time to mention that, in Scylla, you can start with 100 gigabytes and you can grow as much as you want. We have customers that immediately started with 10 terabytes and we even 10 terabytes per node, like customers that use very, very big storage nodes. So that's another thing. And customers that started small and just grew over time, basically either scaling out or scaling up, which for Scylla is exactly the same thing. It's very linear.
Exactly. And I think that's really important to mention, is a lot of people think like, oh, Scylla is only for these really huge workloads. But we did an analysis, and I showed that slide earlier where there's this huge scatter plot. There's a lot of people, there's a lot of clusters that never got past a terabyte. And then there's a lot of, like you say, out the gate 10 terabytes and bigger, right? So The good news is that regardless of your scale, you don't have to switch out your database. It's going to be the same database from small to big, right?
Exactly. And we have some customers that are on the hundreds of terabyte size,
Yes.
but their workload and their throughput is not that big. It can be a few thousands of ops per second, but they are very storage intensive use cases.
Yeah, and what I found interesting is that there are a lot of use cases out there where latencies can vary dramatically. We have some customers who they want to have sub-millisecond latencies, and there's others that 100 milliseconds is fine, right? So again, Scyllla's got this really awesome flexibility. Are you talking ops per second? What do you mean by big data? Is it fast data in terms of latency? Is it, and the good news is that, again, the same database works for all these use cases.
Exactly.
All right. So, I mean, I guess we've been dancing around this question, but really, is the cloud just someone else's computer?
The short version is yes, of course, it's someone else's computers. It's the cloud vendors' infrastructure and data centers. And as I mentioned earlier, it's all based on availability of instances in region and your quotas. For example, we've seen that with some instances being deprecated, like the i2s when the i3s became more common. Now we're seeing that with, for example, the T2 micro, which became almost unavailable in most regions, which is being replaced by the T3 family. And probably now with the i4 family starting to being rolled out, that's going to again with the i3s that are going to be starting to getting decommissioned in the next year.
Yeah, now what's really interesting here is that when you talk about the i4 series, there are actually three different families. Two of the new i4 families are actually based upon the ARM architecture, the Graviton 2 systems.
The Graviton 2, yeah.
And so there, we actually have to provide a different binary to run on those architectures. So it really is somebody else's computer, because you can tell we're running this binary on it. Exactly. But fortunately, though, the new versions of Scylla do run on the Graviton 2-based systems, and we will be showing our performance on the new Intel-based i4i series at Scylla Summit. And even though these are somebody else's computers, these are fast computers. These are pretty amazing, and I can't wait to. I can't say today what we're going to talk about at the show, but you want to be at the show to hear these numbers. This is going to be good.
Yes, and again, yeah, we are in the process of certifying and software testing by our QA, also on the Graviton instances. So we will have dedicated and properly AMI for all of these instances, depending on the instance you choose. And of course, in going back to the i3 family, as you know, there's the i3 and the i3EN, which is a different family, which is more storage oriented. So these boxes can go up to 60 terabytes of storage per box, the i3EN24XL or the metal. And you'll be surprised, but we also have a few customers that are using those. So not many databases can hold around 30 to 40 actual data on a single box, in a box that has 60 terabyte storage. Of course, you need to maintain storage to RAM ratio, but these boxes are already maintaining that, and Scylla certified them and as being a very good and had very good partnership with AWS, always being one of the first vendors that AWS launches and demonstrates the capabilities of these great machines like the i3 and the i4s now, because Scylla can basically push those boxes to the limit.
Yeah, I remember all the benchmarks for the i3 metal, and that's 15 terabytes, right? And people thought that was big, right? Yeah. And then you had 60 terabytes, which is very storage heavy on the i3EN. The interesting thing about the i4i is that it kind of maxes out somewhere between the two. It's at 30 terabytes maximum. So it's twice as much as the i3 metal, half as much as the i3EN, but the new processors are going to scream, and I think people are going to be really happy with the performance. It's also based upon what's known as AWS's new Nitro architecture. Yeah. And in fact, we are going to have somebody from AWS explaining all about what Nitro is going to mean for the public cloud users. So I really, really recommend that. So when we talk about the cloud being somebody else's computer, it pays to see what's under the hood. It really is going to be worth the price of admission for Scylla Summit.
Exactly.
Okay. Is data volume itself a barrier to scale? If a boss came along and said, I want a petabyte of storage fully loaded on the cluster by 8 a.m. tomorrow, are there realistic issues in terms of just managing data at scale like this?
Of course. So even provisioning more machine you need to join them to your existing cluster, and that means you need to start streaming the data to them. For example, in Scylla, it's a ring architecture. The ring needs to be redistributed for the number of nodes. Data needs to be streamed. The existing node needs to later on relinquish the data. They're no longer serving as a replica. So all this, there's a lot of heavy streaming going on. And even if you brought in the best hardware, but you spec'd your network on 1 gigabit, then you might be hitting now a network bottleneck. So you always need to make sure that you are not just thinking about the compute and the CPU and the RAM, but you're also thinking about possible network bottlenecks.
Even storage I/O throughput. Right?
Exactly, and also the operations per second and your disk bandwidth. Okay, you could be using some machine with EBS drives or persistent drives in GCP, and these are not as fast as the locally attached SSDs and NVMe ephemeral drives. So again, you need to make sure that whatever you're planning, you know what's the maximum capabilities of your underlying disks.
Yeah, and I think this also gets into, we were talking about architecture and how your system needs to be architected right. In the past, or even in the present, like for Cassandra or even for Scylla in like the current versions of the system, you have to spin up a node, rebalance the cluster, then add a new node and spin up a cluster, and then rebalance everything, I should say, spin up another node, rebalance the cluster. And so all of that takes a kind of a hit, and you can't just double the cluster. But now I think that we're going to be adding a Raft based consensus protocol, and that's going to allow an arbitrary number of new nodes to be added to the cluster. Isn't that true?
Yes, exactly. So the Raft is going to be a game changer. You'll be able to hear more about that also in Scylla Summit, where we're going to talk about the open source 5.0 version and all the goodies that comes with it. So yeah, it's in Scylla. It's going to be much easier. Even today, it's pretty easy to double and triple your clusters. We have customers doing that a few times a year for sporting events, for Black Friday, Cyber Monday, Chinese Bachelor, whatever you want to name it. And so people are doing that all the time, and it's going to be even easier. And again, it's always important to keep in check your bottlenecking points, which can be either network, storage, RAM, or CPUs.
Yeah, and in fact, there's also, for people who haven't seen this, there's a really good benchmark comparison between Cassandra 4.0. Everybody's really excited. It came out last year, after 3 years of development. It actually is much, much faster than Cassandra 3.11. It's great. And our benchmark covers both Cassandra 3.11 versus Cassandra 4.0 and shows those improvements. But then it also compares it versus Scylla 4.5. And what I found interesting is that although this streaming, provisioning a new node and streaming and rebalancing the cluster is faster, that the time it takes to add for the time it takes Cassandra to add one new node, we were actually able to double the cluster side add. If you have 3 nodes, go to 6, right? And that took as little time as it took for Cassandra just to add a single node. So I think it also behooves people to take a look at how fast their infrastructure is at being able to dynamically change these.
Exactly. The streaming is something that we've been working hard on by Scylla Engineering to improve. There's a lot of improvement in that area, and again, there's also the gossip protocol. When you're adding more nodes, gossip needs to chit chat between all the nodes and having everybody aligned. And there could be situations where the gossip it's also getting overloaded in the sense that it's not able to get the proper sync between all the nodes, and then you can get a possible schema out of sync or some nodes being flagged as down while they're actually not. It's just the gossip not able to get the acknowledgement from all of them. So all this stuff are big improvements in Scylla, and that's what allows us to scale much faster compared to Cassandra.
Yeah, I think Gossip is one of these interesting things, especially because if you lose a seed node in Gossip, you've got a lot of manual tinkering to do to get back out of that situation. So one of our engineers, Asias, did a great job of getting rid of the seed node concept entirely, right? Yeah. Can you describe that more?
Yeah, so I don't recall which version it was introduced, but now basically there was a lot of things that were, quote unquote, unique to a seed node, and then you had to promote a different node to become a seed before you can replace the seed node that died. So some of this stuff are now alleviated by the fact that some of those special characteristic that was only unique to seed are now can be served by any other nodes in the cluster.
Right. So nodes are more homogeneous. There's none of this manual tinkering or real-time panic having to go in and reset up a seed node. So exactly. Again, I think for the audience here, I think that's important, is take a look at to see how resilient your system is, because that one single point of failure is a thing that's going to hit you every time.
Exactly.
So
yeah.
Let's see, what are some other real-time limits you can't avoid? I mean, I always take a look at the latency of the speed of light. If you're serving users in Europe out of a US data center or Asia Pacific out of the US, there's literal time delays there. And there's also, like you're talking about, raw time to stream data over a hard disk drive, right? So exactly. What are the kind of real-time issues should architects be looking at?
Again, you need to consider geolocation of your applications. That's very important. You want to have the proximity of your data set. The proximity of your data center to your applications, so they won't have to sustain long network hops, lags, and also to make sure that you are satisfying the queries and the consistency level that you wish from the local data center. So not, for example, if you're using replication factor 3 and you're doing a quorum query, you don't want that quorum to be satisfied by one data center from Europe and a second data center from the US. That's just very long delay. So you need to make sure that you are also adjusting your consistency level to always be local
quorum,
local one. And again, to make sure that each application client knows which data center is considered the local one. So that's the one you should be connecting to as a priority, and only if that data center is having issues, there's always a fallback if you're using the correct connection method with the round robin option to fall back to the other data center. So geolocation is very important. Another thing is again, we mentioned that earlier, that some softwares may not be able to fully use your infrastructure by not being written for asynchronical parallel processing, okay? And to deal with high concurrency. So Scylla is written in a way that it is able to use async parallel processing and can sustain very high concurrency, but something that you can go wrong is by throwing with unlimited concurrency, which then does exactly the opposite. You're basically starting to hammer the database with endless concurrency. Timeouts may start to arise. Then your application might go into retry mechanism mode, and then the retries overload the cluster together with the unlimited concurrency, and you're getting what we call a retry storm. Okay.
Right.
So basically,
you want to go as fast as you can.
Like a snowball, just becoming worse and worse. So
yeah, so you want to go as fast as you can, but not faster, right?
Exactly. High concurrency is very important, but remember not to do unlimited concurrency.
Fair enough. Okay. By the way, I want to go back to this one. The one thing I want to also point out, because Avi Kavidi, our CTO, is going to be talking about this. So that time to actually stream your data to the new hardware, part of that is based upon, let's say, disk performance. And he is going to be showing off a tool he's been working on. It's been around for a while, called Disk Explorer. But he's going to show off how it's been updated in the past year to actually be able to kind of like benchmark your disks. And that kind of data will be used when Scylla's first installing to help configure it to understand like how fast can I pump data to this hardware so that the system's not trying to overload. The system should be smart enough to understand what that maximum throughput is in its configuration.
Exactly. So Scylla is a self-tuning database. When you're deploying Scylla, there is a script that you run, and it checks a lot of things. Among them, it's benchmarking your underlying disks. And by that, it can set up several parameters that Scylla require in order to know what's your maximum ops and parallelism that your disk are able to sustain. And beyond that, just going beyond that won't help. You're just going to flatline and just start incurring more and more latency. So Scylla wants to know how it can push the disk to the maximum without hitting that situation of just overloading them more. And the Disk Explorer has been around for a few good years. We keep improving it to make sure that the benchmarking is much more reliable, and it gives better results because Scylla is relying on that.
Yeah, and I hate to bash programming language because I know it's so beloved, but Java, for instance, was written in this concept that you're always going to be inside the sandbox, and you didn't need to worry about that hardware, right? Yeah. But I think that this shows that having this deep knowledge of what's going on in the OS, what's going on in the kernel, and what's going on in your hardware layer is important to tailor the database to best utilize the system you're running in.
Exactly. So there's a lot of goodies that you can do with a low-level Linux and kernel space and user space and utilizing C++ that Scylla does in order to basically, get the maximum out of your underlying hardware, which many times many databases do not do that and just expect you to throw more and more hardware on it. That's why sometimes what Scylla can do with a 3, 6, or 9 node cluster, some other databases requires tens, if not hundreds of nodes.
Yeah, exactly. And a lot of users are used to taking a look at their CPU utilization, and it's way south of 50%, sometimes 20. Maybe they're racing at 30 or 40% CPU utilization, and so they run multi-tenancy because there's a lot of spare CPU cycles they have on that box, and they're not using it with the database. But with Scylla, a lot of people panic when they first install it because they see us running at near 100% utilization. But that's because we're a greedy system and we want to utilize all that and have it all available so that as soon as that throughput hits, we have all those resources reserved.
Exactly. And like metrics like using top, a Linux command top is not the way you want to actually see what's going on, because top will always show you that Scylla is 95, 100% CPU utilization because we're always polling on the CPUs.
Right.
If you want to see exactly how much, so even when the database is doing nothing, it's all the time polling on the CPUs and on the processors. If you want to know exactly how hard the database is working, or not that hard, you need to look into the Scylla monitoring, and then we have the CPU reactor utilization, and that will show you exactly how hard Scylla is working. And if you want to keep your latency as a check, if you want to get the best result, usually you need to keep your CPU reactor load under 60%, but it can go even up to 100 because there is, as we said, there's other background processes going on. There's compactions, there's repairs, there's streaming that might be happening. So all these stuff can accumulate, and even if you see a specific shard spiking to 100%, that doesn't mean that anything went wrong, and that doesn't mean you'll start paying with latency. Above the 100%, things will start manifesting in more latency usually.
Very good. Okay, so let's take a look. We were just talking about latency, so let's take a look more at latency issues, right? Sometimes even throwing more hardware could actually worsen your latencies. But talk about latency issues for a systems architect's point of view. What should they be keeping in mind?
So latency problems are often not due to lack of resources. It could be sizing and bottlenecks, but often it's just bad application design. People usually don't know how to reason latency. They think it's just a software product issue or a hardware problem, but it's actually can be coming from the application design. Okay, they might be setting themselves up for bad latency with bad data modeling or inefficient queries, or unlimited concurrency that we mentioned. All of the things have very good observability and monitoring. In Scylla, we have what we call the CQL optimization dashboard. It can tell you what you're doing wrong from the application perspective, right? So if your queries are inefficient, you're not doing prepared statement, you're doing reverse queries, you overlook the fact that your clustering key is ordered by ascending and all your queries are going with descending.
Right, so you're doing a reverse query.
A reverse scan of the table. So there's a lot of other great panels there that can tell you what you're doing right or wrong. Now, bigger clusters, basically, we talked about throwing more hardware. So bigger clusters mean more intranode communications, more streaming that will need to happen. And just statistically, the bigger your nodes are, the more likelihood you can hit either a disk failure or a node failure, right? If you have a 3 or 6 or 9 node cluster, then you have some percentile of chance to hitting those. But if your cluster is 300 nodes, that chances go up dramatically, and it might mean that you'll be hitting those disk or hardware issues on a weekly basis.
Yeah, and when you talk about that, like, so for instance, if you have let's say a 3-node or 9-node cluster, the chance that you're going to be, let's say just with Cassandra, let's take Scylla out of it, let's talk about Cassandra. The chance that you're hitting actually one of the replicas of that data is pretty solid, right? Because you have a small cluster. But once you get to 1,000 nodes or so, the chance that you're hitting the actual cluster, the replica, is really low, right? And so then now you're talking about a hop off a coordinator node, right?
Yeah.
Now, another thing that a lot of people aren't aware of with Scylla is that, for instance, we have a shard aware client so that it knows the token awareness. It knows how the partitions are spanning all the different nodes. So it will always go to a coordinator node that is one of the replicas of the data.
Yes. So the coordinator node is the token aware, which is something that also exists for Cassandra and Cassandra driver. We added the additional layer of optimization beyond the token aware, which is called shard aware. So not only hitting the correct coordinator node, which will be serving as a replica for your data, but inside the node, because of the Scylla sharded architecture, you will be hitting the correct shard inside. And when you're using big machines, which can have 64 virtual CPUs and or more, or hard bare metal that has 64 cores, 128 hyper threads, you need to make sure, and each one of those can become a shard in Scylla. You need to make sure you're going to the right one, so to save the internal hop inside the node.
It's the internal hop. Okay, good. Thank you for that
Second
clarity.
thing is that our shard-aware drivers will also manage will always optimize the number of connections that you have to the cluster. It's always best practice in Scylla to have at least one connection per shard from each of the application clients, sometimes even 2 connections per shard. And when you're not using the Scylla shard-aware driver, you need to maintain that connection pool on your own. And many times users get it wrong. They don't open enough connections, or they open too many connections. And the shard-aware driver always optimize that and make sure you're balanced and connected to all shards properly.
Got it. Okay, thanks for the clarity. That's great. Okay, we are getting close to the top of the hour, but here's one last question. What advice could you give for system architects? We may have people who are already practitioners or people who are listening today that want to move into a systems architecture role. So what kind of advice can you give them for planning to manage and design for data at scale?
So a properly sized cluster will need to account not only for your incoming real-time traffic, your bursty traffic planning, and your P95 or P99 requirements. There are also background maintenance operation, right? Not just the throughput requirements like repairs, compactions, streamings, and scaling operations, replacing nodes, maintenance. So you need to account for all these things, and a good architect understands that there's a lot of these background processes, and these can contend with your general operations.
Right.
So make sure you take all this into account, and make sure that you know that whether you're running on-prem or on cloud, you have the needed resources, quotas, or additional hardware to be able to do also what we call an emergency scaling if needed.
Right. And then the inner chaos monkey in me says, like, also be prepared to, like, when you're testing your clusters, pull the plug on one. Like, how does the system work with when it's taken one torpedo or two torpedoes, right?
Exactly.
So when you're planning, find out exactly how fragile or anti-fragile your system is going to be.
Yeah, and one of the things we emphasize a lot in the technical customer success when we're onboarding customers is not only to make sure you have backups, but to make sure you also tried at least once to restore from a backup, right?
Right.
You do not want to start fiddling with the restore procedure for the first time when something bad happens, right?
Exactly.
So many people have backups, but they never went about to try and, okay, let's kill this cluster and try to restore to a new one or something like that. Or even if you have multi-data center, let's kill one data center and let's see that all application clients quickly cut over to the second data center. And then they find out tons of problems of configuration on the application side of things. So there's a lot of things that you can do to test yourself, like fire drills, right?
Yeah, in fact, with that one customer that had the data center outage, I think that was the thing they found. Scylla was no problem, but there was all these ancillary services they also had running, and some of those had panic conditions that they needed to restore to,
Exactly, yeah. So again, it's very easy. There's tons of application going on. There's networking issues. There's the database. There's a lot of moving parts that you need to make sure that all of them are configured properly, and it's very easy today to miss some configuration. Of course, you can try to mitigate some of this by using more and more scriptology, Ansible, Terraform, and stuff like that. But while people are still catching up to a lot of these issues can happen. So it's always good to do fire drills and to do that before you go live into production. Also, do a topology change after you introduced a third data center or a fourth one. Don't assume that everything that you tested on your previous topology is still intact with the new one.
Very good. Okay, well, that's the questions I have for you today, Tomer. Let's try and see whether we can see if there's anything from the users here. And what I'd like to do also, though, so while we're getting these loaded up here, we've been talking about a lot of different topics, but why don't you tell people about university, Scylla University, because I think this is a great resource to continue this conversation.
Yeah, so Scylla University was launched, I think, roughly 2 years ago, and it's been growing super fast. The user base of Scylla University is growing very, very rapidly. We're getting hundreds and thousands of people registered, and thousands that probably already completed their Scylla University and got their certificate or their diploma. It's a free online tool that will teach you anything you need to know about NoSQL as a starting point, and then everything that is in the Scylla Cassandra space, and then dives into the Scylla specifics, although starting from the basic architecture to the read path and the write path and all the features, and how to write better applications, and how to use our monitoring and our Scylla Manager, which is our proprietary tool for managing your repairs and backups. All this stuff has many, many courses. Many of them has Docker examples for you to actually get your hands wet with online stuff, not just read and answer questions. There are quizzes, and we keep adding more and more courses. Now we even recently added a few courses about how to create a specific use case and how to better program with specific application drivers. Like we do that with Rust. We have one for Python and a few more.
The Rust driver is really cool, and we're going to have another talk about the Rust driver at Scylla Summit. Speaking of which, I want to put up here an offer that we have. I think we have this offer here to have you guys come to register at Scylla Summit. It is February 9th and 10th in the Pacific Coast. It'll be in the mornings of both days, so that should make it early enough for even our European users to attend. It's going to be a lot of fun, and I really recommend that you guys come and register. Let us know if you have any questions about that. And let's see, I'm going to just close that out here. I also want to recommend for people that want to stay connected to our community, we have a very vibrant Slack community, slack.scylladb.com. Definitely recommend that you join us. And with that, I just want to thank everybody for attending. I want to thank you, Tomer. I want to thank Cody also for hosting here. And this has been a great hour. I hope you guys have learned a lot, and I know I'm always learning myself.
Great, and thank you all for attending. And if you have any questions, you're welcome to post them in the Q&A chat section. Both Peter and I will be happy to answer those. And yeah, our user Slack is very, very vibrant. We have over 3,000 users in the general Slack. And we also have a lot of dedicated user Slack channel, for example, Kubernetes, for the Scylla operator that we have for Kubernetes. We have that for specific features like consensus, lightweight transactions. All of this have specific dedicated Slack channels. So once you join the Scylla users workspace, you can basically just search for the relevant keywords or topics, and you'll probably find those Slack channels, and you can join them, where you have access directly to the Scylla engineers working on those stuff. So if you have a question about lightweight transactions or CDC or gossip or Scylla operator, you're going to have direct access to the engineering team that is working on them, including the rest of the community that already joined those channels.
Hey, Tomer, speaking about questions, we do have a live question here. I wanted to throw it out to you. NoSQL works with unstructured data. Is that a truth that you can only use unstructured data with NoSQL?
You can use both structured and unstructured. It depends how you work on your schema and what exactly you're going to structure it. Including you need to understand that there's also a few flavors inside the NoSQL space itself. So again, you have the Scylla and Cassandra white columns. You have Mongo that has its own flavor. So it depends which use case you want to go about. Is it a time series use case? Is it something that is an OLAP OLTP use case? And if you have something in mind, you can always reach out to us, and our solution architect will help you understand if Scylla is the best fit for you, and can also even help you with the data modeling tips.
So let me give an example here then. The DynamoDB API that we have, because we're actually one of the few I think we're the only database other than DynamoDB itself to have a DynamoDB API. There, every single row can have its own schema, right?
Yeah.
But then, go ahead.
Yeah, basically, yes. So the Dynamo is what we call a more simple key value, and Scylla is what we call a key value. It can be used for key value use cases, but it can be expanded to what we call a key value because of the partitioning and the clustering key and the all the wide rows that you can add beyond that.
Right.
And using our DynamoDB API, it's very easy for you to move your DynamoDB workload into Scylla without even changing any line of your code. So it will still be the same underlying Scylla internal CQL stuff doing, but it will be, you can basically use the DynamoDB API to communicate with Scylla, and it will do all the underlying parsing.
Yeah, so that would be if you're, again, using like every different row could have its own schema. And then with the CQL interface that we have, our more traditional like Cassandra compatible CQL, then you have columns, and columns have data types and all the rest of it, right?
Yeah, exactly. So, and again, so things will be transparent to you if you're using the Dynamo API for what is going on below in all the Scylla underlying stuff.
Right. And then I think to answer this user's last question then, or last addressing this question then, if you need a table join though, that seems like an SQL. That sounds like a structured query language kind of thing. So table joins, perfect use case for SQL. And yeah, NoSQL systems are just not going to do that kind of thing. That's
exactly.
And I think that's probably a great definition.
Yeah, NoSQL is denormalization, right? If you want, you don't do joins, you basically replicate the data either using something like a secondary index or materialized view from the base table to the new query you want to satisfy. Okay, you cannot do joins. So denormalization is the way you want to go. You might not be able to, might be paying with additional storage, but the queries will be much faster.
All right. And with that, I want to thank everybody who attended again. We're at the top of the hour. Again, Cody and everybody at TechStrong want to thank you as well. This has been a great hour and hope you enjoyed it.
Thank you.
Well, thank you both for being with me today. A quick reminder, today's session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website. Just visit devops.com/webinars. Real quick, to announce the 4 winners of our $25 Amazon gift card drawing. Our winners are Ryan W., Neer B., Kim Chandra P., and Julia A. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't find an email, just check your spam folder. Peter and Tomer, again, thank you so much for being here with us today, for putting together these 10 questions and diving into a real deep discussion about NoSQL and barriers of scaling. So I really appreciate you guys joining me today. I'd like to thank ScyllaDB for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us for all of today's presentation. This is Cody J. Brown signing off. Have an excellent day, and please take a minute to fill out our post-webinar survey.
Thanks, Cody. Thanks, everyone.